Okay, let's talk about rational functions a little bit. So a rational function well, it's got a root word of ratio in there, and ratios are fractions. So a rational function, it's a fraction of polynomial functions. Okay, so they look like, for example, x squared plus 1 over x minus, or x plus 2. That's an example of a rational function. So I've got a polynomial on top, I've got a polynomial on bottom, we've got a rational function. Probably the most simple one would be like 1 over x. That's a rational function. X over 1, I mean, I would just write that as x, but that technically is a rational function because you can write it as a fraction of polynomials. So every polynomial would be a rational function, but not every rational function would be a polynomial. It's kind of like the every square is a rectangle, but not every rectangle is a square kind of thing. Okay, so that's kind of what a rational function is. Let's do a few basic problems with rational functions. One of the first things you know, well, I can't divide by 0 here, right? This can't be equal to 0 because then I'd get a fraction that has something in over 0, which is, it's bad. It blows things up. So we're going to figure out which numbers we can actually plug into x to get things that make sense, that I don't get division by 0. And if we remember back, that's called the domain of a function. The domain of a rational expression, the domain of a rational function, is the set of x values that you can plug in to that rational expression or that function and not have things blow up with division by 0, for example. Okay, so the domain of a rational function or expression is the set of x values that don't cause division by 0. Okay, so in this one, we'll go back to x squared plus 1 divided by x plus 2. We don't want x plus 2 equal to 0. So we don't want x equal to negative 2. If I solve this by subtracting 2 from both sides, right, I get x does not equals negative 2. We don't want that. We don't want that. So we want all x values with x not equal to negative 2. That's our domain. This is the domain of our rational expression. Okay, that's kind of the common theme for finding these, is we take the denominator and we set it equal to 0 and we solve, and those things are the things that we avoid for the rational expression. So let's do another one. So let's find the domain of, say, f of x equals x plus 1 squared times x minus 2 divided by, let's go like x squared plus 5x plus 4. Okay. So the denominator doesn't, it's not factored right now, right? So we're going to factor the denominator and things are going to simplify just a little bit. So I'm going to get f of x equals x plus 1 squared times x minus 2. And if we factor that, I see that it's x plus 4 times x plus 1. Okay. So if I was to simplify this, I could cancel out the x plus 1 and the x plus 1 because we can cancel multiplication with division. Right? I've got two of them on top and one of them on bottom. It would simplify to be x plus 1, because I get rid of one of them on top and one of them on bottom, times x minus 2 divided by x plus 4. Okay, that's simplified. But when I'm looking at the domain, I just want to know what can I plug into this specific function. And if I plug in either minus 4 or minus 1 into this specific function, I'm going to get division by 0 before I cancel. If I plug in minus 1, I'm going to get 0 divided by 0, which we can usually take care of, but we're still not going to include it in the domain because 0 divided by 0 still doesn't make any sense. It's still bad. So we want to avoid x plus 4 times x plus 1 equal to 0. So we'll avoid x equal to minus 4, and we'll avoid x equal to minus 1. So the domain is all reals except x equals negative 4 and x equals negative 1. So that's the answer to find the domain of this rational expression. Even though it simplifies, right? Even though it's simplified up here, I don't have an x plus 1 in the denominator after I simplify, we still don't want to include that minus 1 in the domain. Okay, I'm going to stop there and we'll come back and we'll do some more rational function stuff in the next video.